In this tutorial, I will explain rainfall intensity duration frequency curve for Lahore, Pakistan using CHIRPS and Google Earth Engine. Understanding rainfall pattern is essential for flood management, urban drainage system design and climate resilience planning. Intensity duration frequency curves provide critical insights into how extreme rainfall events behave over different storm durations and return periods. In this tutorial, we will focus on Lahore, Pakistan, a city that frequently experiences heavy monsoon rains, urban flooding and extreme weather events. Using 30 years of satellite rainfall data, we generate IDF curves and compare different probability distribution models to understand extreme rainfall behavior. In this tutorial, I have used CHIRPS satellite precipitation data from 1991 to 2022, a high-resolution rainfall dataset known for its global coverage and accuracy in extreme rainfall analysis. So let's visit the code. So here you can see I have imported all the necessary libraries, and this is the study area and the historical record, which ranges from 1991 to 2022. From the data set we extract, here you can see we have loaded the CHIRPS data and we have extracted the daily precipitation data by using this piece of code, and then we convert the data to data frame. Here you can see. So as this analysis is based on the annual maximum daily rainfall data, so here we have calculated the annual maximum precipitation of this particular record, and then we have used IMD Reduction Formula. Since IDF curves require short duration rainfall data, we convert maximum daily rainfall into shorter duration using Indian Meteorological Department Reduction Formula, which is, you can see the formula over here, this one. This is the formula. This formula allows us to estimate rainfall depth for storm duration of 5, 10, 15, 30, 60, 120 and 360 minutes, making it possible to analyze short duration rainfall intensity. So here you can see, as I have stated this. Now, in the next step, to estimate the rainfall intensity for different determined period, we applied extreme value theory, which models the probability of extreme rainfall events occurring over different time frame. We fit two widely used probability distribution. So here you can see this is a piece of code for the probability distribution, and we have fitted two distributions, that is Gumbel, this one, and the general extreme value distribution. So Gumbel distribution is a classical method for extreme rainfall estimation, while general extreme value distribution is a more flexible distribution that accounts for different tail behavior. By fitting these distribution to the annual maximum rainfall data sets, we can predict the magnitude of extreme rainfall events for different determined periods such as 2, 5, 10, 25, 50 and 100 years. So this is a piece of code which is used for the said purpose, and in the next step we have computed AIC and BIC to compare the Gumbel and general extreme value distribution. To determine which distribution best represent the extreme rainfall pattern in Lahore, we use Akik information criteria and Boysan information criteria. These statistical metrics help to compare model performance. Lower value indicate a better fit. So this is a piece of code for AIC and BIC to compare the two distribution technique, that is Gumbel and General Extreme Value distribution. And the next step, we have calculate rainfall intensity for different return periods. Here you can see we have by using this piece of code. So this is for Gumbel distribution and this one is for the General Extreme Value distribution. And in the next step, we have generated the IDF curve for the aforementioned two technique, that is Gumbel and General Extreme Value distribution, and this will plots both the General Extreme Value distribution and Gumbel distribution. So here you can see this is the results of the two techniques. So we have got this result for the Gumbel and Extreme Value distribution. For Gumbel distribution, the AIC and BIC value are here, while for General Extreme Value distribution, the AIC and BIC value are here. So the AIC and BIC value of Gumbel distribution is lower than General Extreme Value distribution, which suggests that Gumbel distribution better fit this particular data in comparison to General Extreme Value distribution. Here you can see this is the graph of both the distribution type. The solid line shows the Gumbel distribution, while the dotted line shows the General Extreme Value distribution. So here you can see that shorter storm duration from 5 to 30 minutes exhibit higher rainfall intensity decreases as storm duration increases, while longer return periods 50 to 100 years show significant higher intensity, indicating an increased risk of extreme rainfall events. Gumbel and General Extreme Value distribution yield similar IDF trend, but Gumbel performs slightly better based on statistical evaluation. So these findings provide valuable insight for hydrological modeling, flood forecasting and climate adaptation. These results can be used for flood risk management, urban drainage system design, climate resilience planning, agriculture and water resources planning. And this analysis can be extended to other cities by incorporating real-time rainfall monitoring for dynamic IDF curve updates. We can also use machine learning technique to improve extreme event prediction. So one thing should be noted: if you have observed data, so you can use the observed record of precipitation instead of the CHIRPS record. So this is all about this.